fascinating world of chemistry. Here's the chemical reaction. Sulfur monoxide plus chlorine generates for us sulfur tetrachloride plus oxygen. Now you look at those, you can see that they're not all equal. I've got one sulfur on both sides, but I have two chlorines over here and four over here, one oxygen and two oxygens. So we do have to balance this. Now how do we balance a reaction? The process we go through is a simple one. We start with all metals, then we do all nonmetals, then we do hydrogen, and then we do oxygen. Well, there are no metals here. So nonmetals, we'll start with sulfur. I've got one sulfur and one sulfur. We're good. All right, next nonmetal, chlorine. I've got two here and I've got four here. Well, to balance that, I put a 2 out front. That makes that 4. Now my oxygens, I have 1 here and I have 2 over here. So I put a 2. I just messed my sulfurs up. So I put a 2 there and then messed my chlorines up. So a 4 there. But a question came up when they did this process. How much of each compound do I do to make this reaction function? I mean, they tried mass. 2 grams and 4 grams didn't give me 2 grams of sulfur tetrachloride. So they tried volume. 2 liters and 4 liters. Would it give us 2 liters? Nope, it didn't work either. So it came up to the noble, the ever brilliant, the intelligent, the Italians, to come up with a value called the mole. The mole is a unit of chemical equivalence in a chemical reaction. So those numbers we had there, they're all expressed in moles. That was identified by the Italian scientist Avogadro when he came up with a value that 1 mole is equal to 6.2 times 10 to the 23rd, either atoms or molecules. We use atoms if it's a element, and we use molecules if it's a compound. All right, so let's look at a problem. How many moles are 5.07 times 10 to the 24th molecules of sulfur monoxide, SO? Put our given over 1. Now, using our equality from Avogadro's equation, 1 mole is equal to 6.02 times 10 to the 23rd molecules, because we're looking at a compound here, it's a molecules. Put that over 1 and 1 mole on top. My molecules will cross out, and I'll have in moles. Answer you multiply through 8.42 moles. All right? We'll do this one in class. How many atoms are in 2.985 moles of silver? All right, so let's, because of the fact that molecules are difficult to count, and even if I wanted to, way too big, that'll be something easier to use. So we first found what's called molar mass. 1 mole is equal to AM or FM in grams. What is AM or FM? AM stands for atomic mass. That's from the periodic chart. Those are for elements. FM, we didn't talk about that on Friday, formula mass, and that's for compounds, okay? But what happens if it's not a mass? What happens if it's a volume? Well, molar volume, 1 mole is equal to 22.4 liters of any gas at STP. But understand, this is only for gases. Solids and liquids, this does not apply. What is STP? STP stands for standard temperature pressure. We'll talk about that more later when we get to gas laws. All right, so let's look at a problem here. Calculate the mass of 5.88 moles of silver iodide. Again, we want to get a formula now. Silver, Ag, iodide, I, oxidation number silver plus 1, iodide minus 1. So we get 5.88 moles of AgI, and that's over 1. Because it's mass, and that's a compound, we're going to need to find formula mass. Let's take silver and iodine. Atomic mass of silver, 108 grams. Iodine, 127 grams. Remember, we did use, but that was when they're talking about molecules. We're talking masses, we use grams. Add them together, we get that 1 mole of AgI is equal to 235 grams of AgI. So to solve that up, we're going to put 235 grams of AgI over 1 mole. So my moles cross out. Multiply 2, I get 1380. I know if you multiply, you get 1381, but I only have 3 sig figs. That's my answer. We'll do this one in class. Find the volume of 4.07 moles of hydrogen gas at STP. All right, so let's look at one more, the last kind of problem we can give you. Determine the mass of 38.22 liters of nitrogen monoxide gas at STP. So we take our given over 1. Now, it's a volume. Remember that 1 mole is equal to 22.4 liters. So we're going to put 1 mole over 22.4 liters. So my liters of nitrogen monoxide are now in moles. Is that what I want? Nope, I want mass. And this is a compound, nitrogen monoxide. So I need to do formula mass. Nitrogen oxygen, nitrogen atomic mass is 14, oxygen 16. Add them up, we get 30 grams of nitrogen monoxide is 1 mole of nitrogen monoxide. Make that a fraction, 30 grams over 1 mole. My moles cross out, multiply through, 38.22 times 30 equal, divide by 22.4 equal, I get 51.19 grams of NO. We'll do this one in class. Identify the molecules of 13.985 liters of sulfur monoxide at STP. Okay, copy these two. We'll do these in class. Hopefully it wasn't too bad. Take care. Be good.